First, let's look at the anatomy of the biceps muscles. The main muscle in this region is the biceps brachii. The biceps brachii is composed of two heads, named the short head and long head. Although the anatomy of both heads are very similar and don't really have any notable differences in their function. Both heads insert together on the radius, which is one of the bones of the forearm. In terms of the origin site, the two heads split up and originate at different points on the scapula. Although, as mentioned, these slightly different origin sites don't really impact the functions of the biceps, at least not in terms of how they apply to hypertrophy training. The other muscle in this region, which is technically not part of the biceps, is the brachialis. The brachialis is smaller and sits underneath the biceps. It isn't directly visible, but growing the brachialis can still influence arm aesthetics by pushing up against the biceps and increasing the total circumference of the arm. The brachialis inserts on the ulna, which is the other forearm bone, and it originates from the humerus, or upper arm bone. Now that we have explored the anatomy of the biceps, let's move on to what movements the biceps contribute to. The biceps only really have one primary movement they perform, and that is elbow flexion. This is the movement of bending the elbow from a straight position. This is the main function for both the biceps brachii as well as the brachialis. This muscle group also has two other secondary functions, but they aren't all that relevant for hypertrophy training. The biceps will also contribute to shoulder flexion to some extent. This is the movement of bringing the arm up in front of the body. Because the biceps brachii inserts on the scapula, they also act on the shoulder joint in addition to the elbow. However, the brachialis won't contribute to shoulder flexion at all since it doesn't act on the shoulder joint. The other secondary function this muscle group has is supination of the forearm. This is the action of rotating the wrist so that the palms face upward. Again, only the biceps brachii contributes to this movement since it attaches to the radius, whereas the brachialis attaches to the ulna so it doesn't contribute to forearm rotation. A relevant functional consideration for the biceps is the biarticular muscle theory. This theory suggests that a muscle won't maximally contribute to a movement when two opposing actions are demanded of it. In this case, the biceps brachii is both an elbow flexor as well as a shoulder flexor. So for exercises where the biceps shorten at one joint but lengthen at the other, they may not be maximally trained. This is relevant during horizontal rows and vertical pulls where we have simultaneous elbow flexion and shoulder extension. In this case, the biceps shorten at the elbow joint but lengthen at the shoulder joint. This means the biceps likely won't be maximally trained during such movements. We will discuss the practical implications for this later in the video. Now that we understand the anatomy and functions of the biceps, let's explore what exercises are effective for training the biceps. The main exercise category that will be most effective for training the biceps are the various forms of bicep curls. This includes exercises like standing, seated, dumbbell, barbell, cable, machine, and preacher curls. These exercises all primarily involve elbow flexion, the main function of the biceps. So these exercises will train both the biceps brachii and brachialis muscles. It should also be noted that some of the forearm muscles, primarily the brachioradialis, will also contribute to elbow flexion too. The other general category of exercises which will train the biceps to some extent are back exercises like horizontal rows and vertical pulls. This includes any horizontal row like a seated cable row and vertical pulls such as pull-ups. These exercises involve elbow flexion as well as some combination of shoulder extension and horizontal extension, depending on how the movement is performed. The primary muscles trained with these exercises are going to be the back muscles like the trapezius, lats, and rhomboids, but the brachialis will also be involved due to elbow flexion occurring. The biceps brachii will also likely be trained, but probably won't be maximally trained due to the biarticular muscle theory as discussed. Next, let's move on to some setup and technique considerations to help us maximize biceps hypertrophy. Here are a few considerations worth discussing. The first consideration is for the grip type we use during bicep curls. It is sometimes recommended to use different bicep curl variants or grip types to differentially target the biceps, brachialis, or forearm muscles. But does our grip position actually make a meaningful difference as to which muscles are trained? Well, from the evidence we have, there doesn't seem to be a major difference between grip types and bicep curl variants. For example, this study compared muscle activity between cable bicep curls performed with 3 different grips. 10 competitive male bodybuilders performed cable bicep curls with an underhand, overhand, and neutral grip positions. It was found that biceps brachii muscle activity was similar between all 3 grips, with the underhand grip being slightly favorable during the concentric phase and the overhand grip being slightly inferior. Furthermore, brachioradialis activity, which is one of the forearm muscles, saw similar activity between all 3 conditions during both the concentric and eccentric phases. Another study compared muscle activity during 3 different free weight bicep curl variants. 12 resistance-trained males performed standing bicep curls with a straight bar, easy bar, and dumbbells. It was found that mean muscle activity of the biceps brachii and brachioradialis were similar between variants, with no notable differences between them. So overall, it seems that basically any grip or bicep curl variation is probably going to train the biceps well. The only somewhat notable finding is that we may want to avoid curls using an overhand grip position, as this could potentially limit engagement of the biceps to a small extent. Another technique consideration is the degree of shoulder flexion we allow. This refers to how much we allow our shoulders to flex during bicep curls. In other words, how much our elbows move forward. Since the biceps also contribute to shoulder flexion, it is sometimes recommended to actively flex the shoulders during curls to maximize biceps engagement. But does this actually have benefits for biceps hypertrophy? I am aware of one study which investigated this question, comparing the effects of performing bicep curls with or without additional shoulder flexion. 10 competitive bodybuilders performed standing straight bar and easy bar curls with a standard shoulder position and with active shoulder flexion. It was found that biceps brachii activity was a little higher when the curls were performed with active shoulder flexion during the concentric phase. However, there were no meaningful differences during the eccentric phase. And as expected, there was greater involvement of the anterior deltoids when flexing the shoulder, since shoulder flexion is their primary role. So it may be a worthwhile strategy to actively flex the shoulder to some extent during bicep curls. This may increase engagement of the biceps to a small magnitude. Although it is unclear at this stage exactly how much of a benefit this will have on long-term biceps hypertrophy until we have more direct evidence. The next technique consideration worth discussing is the degree of strictness we perform bicep curls with. As we are all aware, a little extra movement from the hips and spine can allow us to lift heavier loads or perform more reps. Sometimes it is claimed that this is beneficial for biceps growth as it permits superior lifting performance. But others suggest that this is detrimental as it takes tension off the biceps and instead engages other muscles to perform the movement. So is it better to perform strict reps or allow some additional movement from other muscles and joints? This was investigated in this study, which compared the effects of arm training using either strict form or training with cheat reps. 30 college-aged untrained men and women performed single-arm dumbbell curls and tricep pushdowns using strict form with one arm and using external momentum with the other arm. It was found that, as expected, the average volume load used during the cheat reps was about double that of the strict arm for both exercises. However, both arms experienced increases in biceps and triceps muscle thickness to a similar magnitude. So there doesn't really seem to be any meaningful benefit or detriment to cheat reps in terms of biceps hypertrophy. When training to failure, the biceps are probably going to be maximally fatigued either way. Although we should also take into consideration the joint stress induced by cheat reps. Because they allow us to lift heavier loads, we may be presenting greater stress to the elbow joint and surrounding connective tissue. This could increase our risk of elbow pain or irritation compared to performing stricter curls. If this isn't a problem, then it probably doesn't matter all that much whether you train with slightly stricter form or use a little momentum. But if you notice that you are developing elbow pain or irritation, it may be worth reducing the load and using stricter form but still training to or very close to failure. And the last technique consideration worth mentioning is the use of post-failure partial reps. This is applicable to most bicep curl variations due to their resistance profile. Most bicep curl variations will be most challenging around the midpoint of the movement, and they are less challenging in the bottom position and in the top position. This means that if we were to train to failure using a full range of motion, we would likely still be able to complete some additional partial reps in the bottom range of the movement. This will likely improve the hypertrophic stimulus of each set to a small magnitude. It should be noted, however, that this won't work very well for some bicep curl variations. Those which are most challenging in the bottom range won't allow us to perform additional partial reps once failure has been reached. This includes exercises such as free weight preacher curls and some cable curl variants which are set up in a way to produce the peak resistance in the bottom position. Next, let's move on to some programming considerations unique to biceps training. Here are a few considerations I think are worth discussing. The first is for indirect training achieved from other exercises. Since the primary role of the biceps is to flex the elbow, other exercises involving elbow flexion will likely train the biceps to some extent. Most notably, back exercises like rows and vertical pulls involve elbow flexion and will therefore involve the biceps. But the question is, how much indirect training do the biceps get from these exercises which are intended to train other muscles? From an anatomical perspective, it would make sense that the biceps probably aren't going to be maximally trained during rows and vertical pulls due to the biarticular muscle theory, as discussed previously. However, there is some direct evidence investigating this topic, although the evidence in this regard seems to be a bit mixed, with some studies finding that biceps training is more effective for biceps growth, while some studies find that back training produces similar muscle growth to isolated bicep curls. For example, this study compared the effects of performing bicep curls versus rows on biceps growth. 10 untrained men performed dumbbell rows with one arm and bicep curls with the other arm 2 times per week for 8 weeks. It was found that muscle thickness of the biceps increased in both groups, but the bicep curls resulted in significantly greater gains. While this study compared the effects of performing bicep curls versus lat pull-downs on biceps growth. 29 untrained men performed either standing barbell curls or lat pull-downs 2 times per week for 10 weeks. It was found that biceps muscle thickness increased to a similar magnitude in both groups. So it seems that the biceps certainly get somewhat of a hypertrophic stimulus from back training. Exactly how much of a stimulus is not entirely clear, and it may differ depending on the specific exercise. If you wanted to try and quantify the volume performed for biceps, I would count each set of back training as half a set of biceps training. For example, if you performed 10 weekly sets for the back, this would count as 5 sets of biceps training, in addition to the direct biceps training being performed. Furthermore, the degree of indirect biceps growth achieved from back training is likely to be a little different between individuals. Naturally, we all have muscle groups which are slightly more or less responsive to training than others. If you are someone with highly responsive biceps, you may get slightly more indirect growth from back training, whereas other people may not achieve the same magnitude of growth from back training and require more direct biceps training for notable growth. The next programming consideration to discuss is the use of shortened versus lengthened biased exercises. While most bicep curls are very similar, some train the biceps in a more shortened or lengthened state. This is based on the position of our shoulder relative to our torso. When our arm is further behind our torso, the biceps are stretched to a greater degree. And when our arm is in front of our torso, the biceps are shortened to a greater degree. With all else being equal, training a muscle in a more stretched position seems to be slightly favorable for muscle growth in most cases. The other consideration is for the resistance profile of the curl variant. This refers to where throughout the range of motion the movement is least and most challenging. It is generally preferred for the movement to be more challenging in the bottom position where the biceps are more stretched, rather than in the top position where the biceps are more shortened. But how much of a difference do these differences in the muscle length and resistance profile actually have on biceps growth? Well, we have a few studies investigating these questions specifically on the biceps. First is this study, which compared the effects of incline-seated dumbbell curls versus preacher curls on biceps growth. 31 resistance-trained women performed either incline-seated bicep curls or preacher curls 3 times per week for 9 weeks. The incline curls train the biceps in a more stretched position, but are also more challenging in the top position and less challenging in the bottom position, while preacher curls train the biceps in a more shortened position, but are most challenging in the bottom position and least challenging in the top position. It was found that the group performing preacher curls saw superior increases in biceps thickness at the proximal or upper region, middle region, and the distal or lower region. The second study had a very similar design. This study also compared the effects of incline dumbbell curls to preacher curls on biceps growth. 63 untrained women performed either preacher or incline-seated curls 2 times per week for 8 weeks. In this case, it was found that the incline curls resulted in superior increases in biceps thickness of the proximal or upper region, while the preacher curls resulted in superior increases in biceps thickness of the distal or lower region. But overall biceps growth was similar between conditions. The next study had a similar design, but used slightly different exercises. This study compared the effects of performing preacher curls versus Bayesian curls on biceps growth. 15 untrained men performed cable preacher curls with one arm and behind the back Bayesian curls with the other arm with matched resistance profiles for 10 weeks. It was found that the biceps brachii saw similar increases in muscle thickness at all sites, with a slight trend potentially favoring the Bayesian curls. The brachialis also experienced similar increases in muscle thickness at both sites, with a slight trend potentially favoring the preacher curls. And the last study compared resistance profiles rather than muscle lengths. This study compared the effects of performing preacher curls with different resistance profiles. 35 untrained adults performed preacher curls with either a cable or dumbbells 3 times per week for 10 weeks. In this case, the cable curls are more challenging in the top or shortened position and less challenging in the bottom or lengthened position, while the dumbbell curls are more challenging in the bottom position and less challenging in the top position. It was found that both exercises resulted in similar increases in biceps muscle thickness, with slightly favorable results seen with the free weight curls, although this wasn't considered statistically significant. So overall, there are mixed findings in the research on this topic, with no concrete conclusions. It seems that both shortened and lengthened biased bicep exercises will be effective for growth of the biceps. In terms of muscle length, it seems that training the biceps brachii in a more stretched position may be slightly favorable if the resistance profile is similar. And in terms of the resistance profile, training with exercises that are more challenging in the stretched position also may be slightly favorable, but probably not to any major magnitude. Furthermore, there may be some slight differences in regional growth when training with more lengthened or shortened biased exercises. More specifically, curls which train the biceps in a more stretched position and which are more challenging in the bottom range of the curl may promote slightly superior growth in the distal or bottom region of the biceps, while curls which train the biceps in a more shortened position and which are more challenging in the top range of the curl may promote slightly superior growth in the proximal or upper region of the biceps. Exactly how much of a visual difference these factors will make over long-term timeframes is unclear at this stage, but it likely isn't going to be anything major. So overall, I think it makes sense to include some variety in your biceps training. Including a lengthened biased movement as well as a more shortened biased curl may be a good idea to maximize growth across the entire span of the biceps. And the last programming consideration worth mentioning is the use of intensity techniques for biceps training. There isn't really a specific definition for these techniques, but they are generally characterized by the use of short rest periods, lighter loads, and training close to failure. Some examples include drop sets, myo-reps, supersets, and pre-fatigue. Intensity techniques are well suited to biceps training for a few reasons. First is because they are low fatigue isolation lifts. This means that other muscles or systems aren't going to be significantly fatigued, regardless of how short our rest periods are. So the biceps are pretty much always going to be the limiting muscle with each set. Second is that intensity techniques generally limit the amount of load that can be lifted. This can be advantageous for biceps training to alleviate stress on the elbow joints. We can achieve an equivalent hypertrophic stimulus using lighter loads, which can be useful if you notice any development of elbow pain or irritation from heavy biceps training. And third is for time efficiency purposes. Intensity techniques usually allow us to complete more total work in the same duration or complete the same work in a shorter duration. If you are training with fairly high volumes and want to complete your workouts in a timely manner, or just want to minimize time spent in the gym, some of these techniques can help us accomplish this. As an example to demonstrate these benefits, this study compared the effects of performing bicep curl training using either traditional training or drop sets. 9 untrained men performed single-arm dumbbell curls with each arm assigned to either 3 sets to failure with 80% 1RM, 3 sets to failure with 30% 1RM, or 1 set to failure at 80% 1RM, followed by 4 additional drop sets. It was found that biceps cross-sectional area increased to a similar magnitude in all 3 conditions. However, time spent training was significantly shorter with the drop set protocol compared with the other 2 traditional training protocols. So the point is that using some of these intensity techniques for biceps training can allow us to limit elbow joint stress and improve time efficiency while being able to achieve an equivalent hypertrophic stimulus to that of traditional training. This may be beneficial for certain lifters depending on their context and goals. Thanks for watching, and hopefully you got something out of this video. Check out flowhighperformance.com for online coaching, training templates, ebooks, and more.